The universe began with a bang. It was an event of unimaginable energy and heat, called the Big Bang. Space and time were born in that instant. Initially, the universe was incredibly small and hot. Then it started to expand and cool. As the universe cooled, energy began to transform into matter. Tiny particles formed, the building blocks of everything we see around us. Imagine a sea of particles, constantly colliding and interacting. This early universe was chaotic and energetic. It was a time of rapid change and evolution, but the universe was still dark. There were no stars, no galaxies, only a vast expanse of hydrogen and helium gas. This is the era we call the cosmic dark ages. It was a time before the first light sources ignited. The universe was shrouded in darkness, waiting for a new chapter to begin. The stage was set for the universe's next grand transformation. Out of the darkness, the first stars would soon emerge, bringing light to the cosmos. These stars, very different from our own sun, would play a crucial role in shaping the universe as we know it. The cosmic dark ages lasted for hundreds of millions of years. It was a time of relative quiet. Gravity slowly began to gather the hydrogen and helium gas. These clouds of gas grew denser and denser over time. Inside these clouds, the seeds of the first stars began to form. These first stars were different. They were much larger and hotter than our sun. We call them population 3 stars. These stellar giants lived fast and died young. Their lives were short but incredibly important. They were the first light sources in the universe. The intense light from these stars began to change things. It ionized the surrounding hydrogen gas. This means that the light stripped electrons from the hydrogen atoms. This process is called ionization. It marked the beginning of the Era of Reionization. The cosmic dark ages were a crucial period of gestation. Gravity worked silently in the darkness. It pulled together the matter that would eventually become the first stars and galaxies. The universe was preparing for its next grand transformation. The Era of Reionization was a time of dramatic change. The powerful light from the first stars transformed the universe. It ionized the neutral hydrogen gas that filled space. This ionization had a profound effect on the universe. Imagine a dense fog. You can't see very far because the fog blocks your view. The neutral hydrogen gas was like that fog. It filled the early universe and made it opaque. Light couldn't travel very far. Reionization was like the fog clearing. As the hydrogen became ionized, the universe became transparent. Light could travel freely across vast distances. This paved the way for the formation of galaxies and the structures we see in the universe today. Reionization was not a sudden event. It happened gradually over hundreds of millions of years. The light from the first stars, and later from galaxies, gradually ionized the hydrogen gas. This process transformed the universe from a dark and opaque state to a transparent and luminous one. As reionization progressed, the universe began to take on a new structure. Gravity continued to pull matter together. Clouds of gas collapsed to form stars, and groups of stars came together to form galaxies. These galaxies were the building blocks of larger structures. Galaxies were not randomly scattered throughout space. Gravity pulled them together into clusters and superclusters. These clusters connected with each other through filaments of gas and galaxies, forming a vast cosmic web. This web-like structure is the largest known structure in the universe. We can't see this web directly. It's made mostly of dark matter, a mysterious substance that doesn't interact with light. We know dark matter exists because of its gravitational effects on visible matter. It's like an invisible scaffold holding the universe together. The formation of galaxies and the cosmic web is a complex process. It involves a delicate interplay between gravity, dark matter, and the ordinary matter we can see. Understanding this process is crucial to understanding the evolution of the universe. Studying the early universe is like looking back in time. Light from distant objects takes time to reach us. When we observe distant galaxies, we see them as they were billions of years ago. Powerful telescopes are our time machines, allowing us to peer into the distant past. One such telescope is the James Webb Space Telescope. It's the most powerful telescope ever built. It can detect the faint light from the first galaxies. This allows us to study the conditions in the early universe and learn about the processes that led to the formation of the first stars and galaxies. Another powerful tool is the study of the cosmic microwave background radiation. This radiation is a faint afterglow of the Big Bang. It provides us with a snapshot of the universe as it was just 380,000 years after the Big Bang. By studying these faint signals from the early universe, we can piece together the history of the cosmos. Each new observation brings us closer to understanding our cosmic origins and our place in the grand scheme of things. The cosmic microwave background radiation, or CMB, is a faint afterglow of the Big Bang. It permeates all of space. This radiation was emitted when the universe was very young, only 380,000 years old. It's like a baby picture of the universe. The CMB is remarkably uniform. The temperature is almost the same in every direction. This tells us that the early universe was incredibly smooth and homogeneous, but there are tiny fluctuations in the temperature of the CMB. These fluctuations are incredibly small, only a few parts in 100,000. These tiny fluctuations are incredibly important. They represent the seeds of the large-scale structures we see in the universe today, the galaxies, clusters, and the cosmic web. Over billions of years, gravity amplified these tiny fluctuations, pulling matter together to form the structures we observe. By studying the CMB, we can learn about the conditions in the very early universe. It provides us with a unique window into the past, allowing us to study the fundamental properties of the cosmos. Reionization marked a turning point in the history of the universe. It transformed the cosmos from a dark and opaque state to a transparent and luminous one. This transformation had a profound impact on the evolution of the universe. Before reionization, the universe was filled with neutral hydrogen gas. This gas absorbed ultraviolet light, preventing it from traveling very far. After reionization, the hydrogen was ionized, and the universe became transparent to ultraviolet light. This allowed light from stars and galaxies to travel freely, illuminating the cosmos. Reionization also influenced the formation of galaxies. The energy released during reionization heated the intergalactic gas, making it more difficult for galaxies to form. This process may have played a role in shaping the distribution of galaxies we see today. Reionization was a complex and gradual process. It's a testament to the transformative power of light and the interconnectedness of cosmic events. Understanding reionization is crucial to understanding how the universe evolved from its simple beginnings to the complex structures we observe today. The story of the universe is a story of change, evolution, and transformation. From the Big Bang to the cosmic dark ages, from reionization to the formation of galaxies and the cosmic web, the universe has been on a continuous journey of change. We are fortunate to live in a universe where we can study these events and piece together the history of the cosmos. We are part of this cosmic story. The atoms in our bodies were forged in the hearts of stars, some of which may have been among the first generation of stars that illuminated the universe. Understanding the processes that shaped the early universe, such as the cosmic dark ages and reionization, helps us understand our own origins. The universe is still evolving, still changing. New stars are being born, and old stars are dying. Galaxies are colliding and merging, and the cosmic web continues to expand. We are privileged to witness this cosmic dance and to continue to explore the mysteries of the universe. As we look to the stars, we are reminded of our connection to the cosmos and the vastness of space and time.